Michio Kaku, Physics of the Impossible, a scientific exploration into the world of phasers, force fields, teleportation, and time travel. Embark on a fascinating journey through the world of seemingly impossible phenomena with Michio Kaku's book, Physics of the Impossible. This captivating summary will unravel the scientific theories and advancements behind science fiction concepts like force fields, invisibility, laser guns, teleportation, mind reading, artificial intelligence, space travel, and time travel. Explore how groundbreaking developments in areas such as quantum theory, nanotechnology, and space exploration are taking us closer to understanding and harnessing these mystifying concepts. Delve into the realm of possibilities as the book examines the science behind these thrilling ideas, guiding the reader through the fundamental principles that govern them and contemplating the future implications of achieving the impossible in our everyday lives.
Creating force fields and invisibility cloaks. Classical physics states that force fields are real. Scientists could use plasma and carbon nanotubes to create deflector shields, whilst metamaterials could create invisibility cloaks. Do you remember the force fields used in Star Trek? Did you know that those energy barriers are not just a product of fiction, but of classical physics? In the 19th century, the concept of force fields was introduced by Michael Faraday as invisible areas or lines that envelop a magnet. This idea expanded to include other forces such as the Earth's gravitational field. Though these force fields are not as exciting as science fiction ones, they could pave the way in creating them. For instance, scientists could use plasma, an electrically charged mass that's neither solid or liquid nor gas, to deflect rockets by molding it with magnetic and electrical fields. This plasma could then take on the form of an invisible sheet or plasma window, which could be further strengthened by a lattice of carbon nanotubes. Carbon nanotubes are thin, rolled-up sheets of carbon and are stronger than steel. But force fields aren't the only application of plasma and carbon nanotubes. An invisibility cloak could be created using a composite material called metamaterials. Duke University scientists developed these materials in 2006, which contain small particles that deflect, rather than reflect, light waves. When objects are concealed in this material, they become virtually invisible. The principle behind this lies in the amount of light a material reflects. If less light reflects, and more passes through, the material becomes less visible, just like what happens with liquids and gases. In conclusion, classical physics is more than just a branch of science. It paves the way for envisioning technology that may have originated in science fiction. The force fields and invisibility cloaks mentioned earlier are just a few ways physicists are turning fantasies into reality. The reality of handheld laser guns. The idea of using handheld lasers or rays of light as weapons has fascinated humans from ancient times to the Star Wars movies. This book excerpt explores the potential of using nanotechnology to create a compact laser gun that could fire multiple times, and the need for a stable material that could withstand the energy. The military already uses lasers in their missile defense systems, but we would need a portable power source to create a functioning handheld laser gun, and we're not quite there yet. While the possibility of a handheld laser gun is not too far off, creating planet-demolishing superlasers is currently beyond our reach. Gamma-ray bursters are currently the most powerful beams known, and while it's theoretically possible to predict and aim them, it's millions of years away. Teleportation, is it possible? According to quantum theory, teleportation is a common occurrence that happens spontaneously. Electrons are in a constant state of motion, taking quantum jumps, meaning they can suddenly vanish and reappear elsewhere within the atom or appear in many different locations simultaneously. Scientists have already succeeded in teleporting trillions of atoms entangled with a beam of light over long distances by harnessing quantum entanglement. However, it's the information about the object's state that is really teleported, not the object itself. Although it is theoretically possible to teleport an object from one point to another, reconstructing it at the destination using the teleported information, teleporting humans could take a little longer, as it can only take place under extreme conditions and could require the calculations of a quantum computer, which is still in a rudimentary phase. Mind reading and biofeedback, technological feats. Have you ever wondered whether mind reading is possible? While there is not enough evidence to prove that psychics can read minds, technological advancements have inched closer to unlocking the ability to read brain activity and interpret patterns into human emotions. MRI technology is aiding scientists in conducting deeper studies in this area, paving the way for developing handheld gadgets capable of reading human brain activity. However, the complexity of interpreting human thoughts still poses a hurdle, considering the brain emits weak electrical signals. Biofeedback is the closest recreation of the phenomenon of psychokinesis, where the electronic transmission of brain waves communicates directly with computers. With implanted chips that can read brainwaves to perform complex tasks or control devices, modern technology presents boundless possibilities. In the future, nanotechnology can be controlled through biofeedback, creating a future that was hitherto considered impossible. Robots lack common sense. Robots can form grammatically correct sentences but fail to understand the meaning behind words and lack common sense. Despite attempts to program common sense into machines and pattern recognition, computer scientists have seen little success. However, MIT professor Rodney Brooks developed bug-like robots that learn to walk through experience, a new approach to creating artificial intelligence like animals and humans. The search for extraterrestrial life. Are we alone in the universe? While the evidence is scarce, scientists have made significant strides towards discovering extraterrestrial life. For centuries, humans have pondered the existence of other intelligent beings in the universe. Thankfully, scientific advancements have brought us closer to discovering the answer. With technological enhancements like improved telescopes and satellite capacity, we have the ability to uncover promising locations for extraplanetary life. Organizations like the Search for Extraterrestrial Intelligence, SETI, project are actively searching for interstellar signals, while also expanding their search criteria for habitable planets. We know that for life to exist, water is crucial, making it a reliable indicator for discovering habitable planets. Additionally, the presence of a large moon and a Jupiter-like planet in a planet's galaxy are factors that contribute to a planet's habitability. Despite these advancements, conclusive evidence of extraterrestrial life remains elusive. The majority of UFO sightings can be attributed to natural phenomena, hoaxes, or secret aircraft projects, with only a small percentage left unexplained. In conclusion, the search for extraterrestrial life continues to be an area of great interest and extensive research. While conclusive evidence has yet to surface, scientists remain optimistic and continue to expand their search criteria. The future of space travel. In the foreseeable future, humanity must find ways to leave the solar system to survive, but how? Science is exploring multiple fuel sources for starships, including ion and plasma engines, solar sails, and ramjet fusion rockets that could yield significant energy. However, there are challenges, such as the size of solar sails, radiation exposure, and the effects of weightlessness on the human body. NASA is already looking into solving these problems, including building a space elevator for constructing large ships and developing radiation protection. The future of space travel may be closer than we think. Revisiting Einstein's ultimate speed limit. Physicists have uncovered two loopholes in Einstein's theory that the speed of light is the fastest pace. Warping space and utilizing wormholes could provide paths faster than light, but they require enormous quantities of negative energy and come with dangerous risks. Physicist Miguel Alcubierre proposed the Alcubierre drive that compresses space while enveloping a spaceship in negative energy to move faster than light. Wormholes are shortcuts between 2 points, but require negative energy up to the size of Jupiter, and come with huge risks of radiation. While negative energy has been detected in minuscule quantities so far, the potential for faster-than-light travel remains hypothetical. The possibility of time travel. Time travel has long been a subject of fascination in science fiction. Although the idea has been contested, the laws of physics and quantum theory do not rule out the possibility of traveling through time. According to Einstein's theory of relativity, traveling at high speeds can slow down time, effectively allowing us to travel into the future. However, going back in time requires the existence of wormholes and vast amounts of negative energy. While time travel presents confounding paradoxes, this may be resolved by assuming the existence of parallel universes. These technologies remain on the fringes of our knowledge, but if they were ever realized, they would require a fundamental rewriting of physical laws. The Holy Grail of Invention. Could dark energy power the elusive perpetual motion machine? Leonardo da Vinci and Nikola Tesla both dreamed of creating the perpetual motion machine, a device that generates more energy than it consumes. While the laws of thermodynamics seem to make this impossible, scientists have discovered loopholes that could potentially allow energy to be extracted from a vacuum. Tesla's experiments with zero-point energy were inconclusive, but today, dark energy found in total vacuums has reignited the possibility. Analysis from satellites indicates that 73% of the universe is composed of dark energy. However, physicists are still struggling to explain or calculate this mysterious force, and only tiny amounts have been found on Earth. If harnessed, though, the power of dark energy could transform our world. The discovery and utilization of dark energy would surpass the significance of previous technological advancements, like the Internet, and even necessitate the rewriting of physics as we know them. While it remains a distant possibility, the pursuit of a perpetual motion machine fueled by dark energy is a fascinating exploration of the mysteries of the universe. Closer to a theory of everything. Einstein spent his life pursuing a theory of everything that could explain the universe's fundamental forces, but he was unsuccessful. Advancements in technology, such as satellites with radiation detectors, are bringing us closer to revealing the origins of the universe and potentially leading to a testable theory of everything, like string theory. String theory aims to tie gravity and relativity to quantum theory by modeling particles as strings that vibrate and interact, with one state of vibration corresponding to the graviton. If superparticles are discovered through the Large Hadron Collider, it could indirectly support string theory as the unifying theory, calling into question what is possible or impossible in physics.
As we have seen throughout the summary of Physics of the Impossible, the intriguing world of science fiction and seemingly impossible phenomena are rooted in actual scientific theories and principles. The book offers a comprehensive exploration of various topics like force fields, invisibility, laser guns, teleportation, mind reading, artificial intelligence, space travel, and time travel, which might appear fantastical but are grounded in the reality of cutting-edge scientific advancements. Although many of these concepts are still beyond our current technology or understanding, they constantly challenge our perception of what is possible and inspire us to push the boundaries of science and human knowledge. Learning from this book, we can appreciate the limitless potential of the world around us and imagine a future where once impossible ideas become realities.